Hi all, today we're going to be looking at integration by parts repeated. Okay, so this is a follow on from the first lesson about looking at integration by parts. So we'll look at a couple of examples to show when we need to do the process repeated. Okay, so example one, we're going to integrate x squared e to the power x with respect to x. Okay, so I've got two functions there, so I need to do this integration by parts. So we're going to pick something to be our u function. If you remember how integration by parts works, we need something to be our v dash function, which means we integrate to get v. Okay, so again, the thing that you look out for, if you're trying to always achieve, we're going to let the x squared be our u. That way, when we differentiate it, the power's going down. And then we're going to let e to the power x be our integral function v dashed, like that. So u's going to be x squared. If I differentiate that, I get 2x. So then if we go down this way, we're differentiating. And v dash is going to be e to the power x. And we're going to integrate that. However, if we integrate that, we just get e to the power x again. Okay, so that's me got my data. I'm now going to go through the formula. So we're going to integrate x squared e to the x dx. And our formula for that is going to be u times v minus the integral of vu dashed dx. Okay, so that's the formula for integration by parts. Right, if we let u times v, so u times v is going to be x squared multiplying e to the x. Okay. We're then going to subtract the integral of v times u dash, that's going to be 2x e to the power x. Okay. Now, we still need to integrate this thing on the far right hand side, but why this is called the integration by parts repeated is because we need to actually still integrate this, and we need to do this by integration by parts again because I've got two functions I need to integrate, or one's going to differentiate, one's going to integrate. Okay, I can't just integrate that on its own. So what to do here, and the best thing I always advise is do this next bit at the side and then we'll put it back into our answer, because I need to remember I'm taking away whatever this is going to come out to give me. Okay, so here I need to pick a u and a u dashed again. Also need to pick a v dashed as well. So here, again, going by the same theory, we want 2x to come down in power, so we're going to let that be our u. And we're going to let e to the power x be our v dashed. There. So I get 2x there. If I differentiate 2x, I get 2. I'm going to make b dash my e to the power x. And we've seen if we integrate that, I get e to the power x again. Okay. So what I'm doing is going to break the page up a little bit. So the integral of 2x e to the power x. Well, it's integration by parts, which is uv minus the integral vu dashed. U times v, that's going to be 2x e to the power x minus the integral of v times u dashed, so that's going to be 2 lots of v to the x with respect to x. Okay, so now I can integrate this integral now. Okay, it's not by parts anymore, it's just 2 e to the power x. I'll use my formula sheet for that. And if I integrate e to the power x, I still get the same thing, so I just get minus 2 e to the power x. And because that's going to be me finishing all my integration, I've got my plus c as well. Okay, so this bit here, that's within the page break, needs to go back into my question. Okay, so I'm going to rewrite my question down now. So the integral, which was originally x squared e to the power x, well, it started off being x squared e to the power x minus the integral 2x e to the power x dx. Okay, so that's just me where I got up to before I have to do integration by parts again. So then I get x squared e to the power x minus, okay, so I know the answer for the integral of 2x e to the power x, so it's be minus 2x e to the power x minus 2 e to the power x. Okay, And you can just write plus c outside, okay? The sign on it doesn't really matter at this point, okay? If I just tidy this up, I get x squared e to the power x minus 2x e to the power x. That minus outside the bracket will hit the last term, which make it plus 2e to the power x plus c, okay? And then just lastly, I can take a common factor of e to the x out, so I'll get x squared minus 2x plus 2 plus c. Okay, so that's me. I had to use integration by parts, but I had to do it twice because when I done it the first time, I still had integration by parts part to my integral. Okay, okay with that first example? Okay, I'll give a second example to show you, and then we will practice some questions on that. So example 2. So again, we're going to let it be the integral of x squared sine x dx. So in the very first lesson we've seen, it was important to try and work out what the right u and v dash was, and now after seeing that last example, you might understand why it's important, because if I made this x squared become my v dash, which means I integrate it, it means that the power is going to go always up and up. It means it's going to repeat itself all the time. I'm going to have to integration by parts all the single time. So that's why you do try and bring your power down. So we're going to make that u, we'll make that our v dashed. So u is going to be x squared, v dash is going to be 2x. We differentiate it. V dashed is going to be sine x. Remember, I'm integrating going this way. So if I integrate sine, I get negative cos. Okay, if you differentiate sine, you get cos. So if I integrate it, I get negative cos. Okay, so x squared, the integral of x squared sine x dx becomes uv minus the integral of v u dashed dx. Okay, u times v, that's going to be negative x squared cos x. Okay, minus the integral, okay, v times u dash, that's going to be negative 2x cos x dx. Okay. So you can see I'm going to have another integration by parts to do again here. However, I'm going to tidy this up just ever so slightly because it's going to make my life a lot easier. That I'm going to bring the negative outside the integral to hit with this integral. Which will make my life a bit easier. Okay, so I've just took the minus out the integral, put it out to the front of it to make it a plus. So again here, we'll put in by parts again. So we need to make a u and a u dashed. We need to make a v dashed and find a v. So again, we're going to make 2x or u. So we're going to differentiate that goes down in power, so we get 2 there. And v dash is going to be cos. Remember, we're integrating cos to get v, so if I integrate cos, I get back sine. Okay, positive sine. Okay, we'll put a wee break so that we can work out what that's going to give me. So the integral of 2x cos x, well, it's still by parts, so it's uv minus integral v u dashed, respect to x. Okay, u times v is going to be 2x sine x minus the integral of v u dash, that's going to be 2 times sine x dx. Okay. So I no longer have integration by parts, I can just integrate what 2 sine x is. Sine integrates into negative cos, so it's going to be minus negative 2 cos x plus e. The two negatives will cancel to give me plus 2 lots of cos x plus c. Okay, so that's me now done all my integration. I just need to put it back into the question. So the original question was the integral of x squared sine x dx. And up to that point we've got negative x squared plus, sorry, for the cos x part. Negative x squared cos x plus the integral 2x cos x. So that's what we got up to. So the answer for that part became 2x sine x plus 2 cos x plus c. The reason why I kept it in brackets was just in case any signs had to change, but we can see here the signs won't change anything, so we just get negative x squared cos x plus 2x sine x plus 2 cos x plus c. Are we okay with that?